Hello and welcome to this video of our Unity C# series. Today I want to talk about arrays. But what is an array? To explain this, I want to go a bit into the details actually on how an array is working in assembly, so in the background. And I do that because it's very important for a programmer to know how things are working in the background, because only then he can act accordingly while using his higher programming language. But before I talk a bit about the background, let's talk about how it's working in the higher programming language, so how it's working in C#. So an array is basically just a number of variables that you can save under one name. So basically you can have an array, and inside this array you can save, for example, if you declare it like this in the beginning, you can save 5 numbers. To give you an example, let's create an array in which we can save 4 strings. Let's call this array fruits and let's save some fruit names in there. To create an array, start with the data type, followed by an opening and closing square bracket, followed by the array name, then write equals, new, the data type again, an opening square bracket again, and then in here you need to write the array length, which is the amount of values that you want to save inside this array, then write a closing square bracket and a semicolon. Okay, here we go. We created our first array called fruits. Let's save some values inside. You can imagine an array as a number of slots in which you can save values. It's important to notice that you need to address the value that you want to change by its corresponding number. In informatics, we start counting by 0. That means the first element inside our array is the element 0. The second element is the element 1. The third element is the element 2, the fourth is the element 3, etc, etc. It goes on like this forever until you reach the last element inside your array. We gave our array the length 4. That means we can save 4 elements inside it. But that also means the last element inside the array is the element 3, because we start counting by 0. That means the first one is the 0. Okay, let's try to save the string banana in the second element of our array. Remember, the second element of our array is the element number 1 because we start counting from 0. To do that, write the array name followed by an opening and closing square bracket, and between those two brackets you need to write the element number. Remember, the element number is 1, so we will put the 1 here, then we will write an equals, and then we can write the string banana followed by a semicolon. So to access this element, you just need to write the array name followed by an opening and closing square bracket and the element number again. And that way you can access the value inside this element. Okay, let's try to debug log the second element inside our array. And let's execute this, and as you can see, banana gets printed to the console. If you have a small array and want to assign all the values together in the beginning when you initialize it, instead of assigning them one by one like we did before, there is a simple way to do that. Just write what we did before, but after the equals sign, you will write an opening curly bracket followed by the values, separate them with commas, and then a closing curly bracket followed by a semicolon. Okay, that's all I want to say for now about one-dimensional arrays, and before we talk about multidimensional and jagged arrays, let's talk about the background of an array. So what is the background of an array? An array is basically just an addressable region of continuous volatile memory. That means that in the assembly background of our higher programming language, the array that we just created is just a big field of memory. And this sentence that I told you before was actually super important, so listen carefully to every word that I said there, because I said continuous region of memory, and this is actually explaining why you need to define the size of an array beforehand. And why is that so? Because if you define the size of an array beforehand, the memory for this array can be reserved. And this is pretty simple. For example, if you are using integer, so you want to create an int array, then one integer is 32 bits. That means if you want an int array for 4 integer values, then you need 4 times 32 bits. And this region of memory needs to be continuous and in one row. And that is also pretty important because that is leading us to the next big question. Why does this big chunk of memory need to be together? Why does it need to be continuous? And that is pretty simple because of the way how we address it. If we think about it, what would be a fast way to address this memory in the background? So a fast way would be to say, okay, we have an integer array, for example, like I said before, with the 32 bits for one integer. Okay, so if I want to access the first integer, I have this address, yeah, in the memory. So I have this memory address, and I say this memory address plus 0, because it's the first integer anyways. Then if I want to access the second value inside our array, I can just say this address of our array plus 32, because one integer is 32 bits long. So after 32 bits, it should be the second integer. And like this, you can address every value inside your array. And that's pretty simple and super fast. So to access the third value in the array, for example, try it out yourself. You need to say the address of our array plus 0 would be the first, plus 32 would be the second. And what do you need to do for the third? Easy. 32 times 2, so plus 64. And this would be the third value of our array. And that's why I wanted to explain to you the background of an array, because I think now you can really understand how an array works in the background, and that this is super fast and it is super easy to work with, but you also understand the limits of an array. For example, you understand that you can't just add more size to your array because it needs to be a continuous region of memory, and maybe behind the memory of your array there is a variable saved, so you can't just expand that array. That means if you want an array, for example, after you had one with 4, and you want an array with 6 numbers now, then you need to create a new array. You can't just expand the old array. And also, maybe you understand what the array itself just is. Because the array itself is just the memory address that points to the first bit of the array. And the first bit of the array is the first bit of our big continuous memory region. And now that's how it's working in most of the programming languages. In C# it's a bit different, but just a little bit, because arrays are actually objects as well in C#, but it's still a big addressable region of continuous volatile memory. And in the end, it's important for you to know how an array works and that this is super fast. And if we will talk about linked lists later, you will understand why they are so much faster than linked lists, but you also understand the benefits of a linked list because it is expandable as much as you want. But no worries, we will talk about linked lists in a later video. Now let's talk about multidimensional and jagged arrays. So what is a multidimensional array? To explain this, let's start with the easiest one. Let's start with a two-dimensional array. For example, if you have a two-dimensional matrix, that would be pretty similar to a two-dimensional array. Or if you have a table with rows and columns, that's also pretty similar to a two-dimensional array. A one-dimensional array would be a table with only one row. A two-dimensional array would be a table with a few rows and a few columns inside. So let's imagine a two-dimensional array for a second, and this two-dimensional array is 4 by 4. That means we have 4 rows and 4 columns, and that means we have 16 elements in total. So in this example, if we would like to access the second element inside our first row or the second column inside our first row, we would need to write our array name, followed by an opening square bracket, followed by the 0, because as I mentioned before, the first row would be referenced by 0, followed by a comma, followed by a 1, because column 2 or element 2 would be referenced by 1, followed by a closing square bracket. Let's do another example so you understand that a multidimensional array is basically exactly the same like a multidimensional matrix, like you know it from the mathematics. So let's try to access this element. And how would we access this element? Exactly, we would write 2, 2. And if we would like to access this element here, one side to the left, we would write 2, 1, because it's in row 3, which is accessed by 2, and it is in column 2, which is accessed by 1. So 2, 1. Okay, I hope now you understand how a multidimensional array works and how you can access different fields in a multidimensional array. And now let's try to create one. Let's create a two-dimensional array. To do that, let's write int, followed by an opening square bracket, followed by a comma, followed by a closing square bracket. Then you write the array name, an equals new int, followed by an opening square bracket again, Then you write how many rows do you want to have, comma, how many columns do you want to have, and a closing square bracket. After that, write a semicolon, and hooray, now we created our first two-dimensional array. Now we have a two-dimensional array with 4 rows and 5 columns per row. Okay, but now let's try to create a three-dimensional array, which is basically exactly the same like a three-dimensional matrix. To change our two-dimensional array into a three-dimensional array, we just need to add 1 comma inside the first pair of square brackets, and inside the second pair of square brackets we need to write 1 comma, followed by the number of elements for our third dimension. Okay, but let's revert that again into a two-dimensional array, because I just wanted to show you how to create a three-dimensional array, but for now it's way easier to work with a two-dimensional array. Let's quickly assign a value to our spot 2, 1 in our array, and to do that we will just write the array name followed by an opening square bracket followed by 2, 1 followed by a closing square bracket. Then we write an equals and the value that we want to assign. And to read that value again, we will write a debug log, and inside we will just write our array name followed by an opening square bracket followed by 2, 1 and a closing square bracket, and like that we can access the array value on this position. Now let's move on to jagged arrays. Jagged arrays are arrays of arrays and are basically pretty much the same like multidimensional arrays, but they can be used more effectively, and most important, they are faster than multidimensional arrays. That's why you should always prefer to write jagged arrays instead of multidimensional arrays. Because jagged arrays can basically be used exactly the same like multidimensional arrays, and on the higher level are also structured the same, because they are also exactly the same like a multidimensional matrix, like from the mathematical point of view. And because of that, I will only show you an example and not go into the details, because it's not necessary anymore. All the details are the same like on the multidimensional arrays. Let's create a two-dimensional jagged array of type int. To do that, let's write int, followed by an opening and closing square bracket, followed by another pair of opening and closing square brackets, because you need to do as many pairs as you want to have dimensions in your array. Okay, now we write the array name, followed by an equals, followed by a new int, an opening and closing square bracket pair again, followed by the second opening and closing square bracket pair. Okay, and in the first opening and closing square bracket pair, we need to write the number of rows that we want to have in our array. But now we won't write the number of columns that we will have in our array in the second pair, no, instead we will leave the second pair empty. So why do we leave the second pair empty? That's pretty easy, because like I said before, a jagged array is an array of arrays. And right now we have a two-dimensional jagged array, and we have 2 square bracket pairs for 2 dimensions. But the second pair is the dimension of the other arrays that are saved in our array of arrays. That means we have an array with 4 arrays inside. But all of these 4 arrays can have a different length. And that's an advantage of jagged arrays, but also that means that we can't just write the size of our columns here, because all of these columns are individual arrays for itself. But that also means that for every row that we want to use in our two-dimensional jagged array, we need to declare the array inside it first, before we can assign values inside that row. So let's use, for example, our row 0, and let's say we want to declare a value for any column inside this row. That means first we need to declare the array for row 0. Let's do that. Let's write jagged array 2D, an opening square bracket, 0, and closing square bracket, and equals new int, opening square bracket, 5, closing square bracket, and a semicolon. And that's it. Now we can assign values inside that row. Now that we have our jagged array, let's try to assign a value inside this jagged array at a certain position. To do that, let's write our array name, followed by our 2 square bracket pairs, and inside the first pair we will write the row, inside the second one we will write the column. Then we will write an equals, and now we can assign a value to it. To access this value again, we will do it exactly the same, but without the equals and without the assigning of the value. So let's write a debug log and access this value like this. What we can also do is to directly assign a complete row to our jagged array. To do that, let's write our jagged array name, followed by an opening square bracket, followed by the number of the row that we want to assign, followed by a closing square bracket. We don't need the second square bracket pair now, because we want to assign the complete row. Then we will write an equals, new int, the square bracket pair again. Inside this we will need to write the number of columns, and then we will do an opening curly bracket, write all integer numbers divided by commas, a closing curly bracket, and a semicolon. Now I want to mention one very important thing, and that is that arrays are reference types. That means that the array is basically just a memory address that points to the first beginning of your continuous region of memory, and the first bit inside this continuous region, that is the memory address that is saved inside your array. And basically in this region, there's maybe like 20 integers, and then you have an array with 20 integers inside it. But the array itself is just the memory address. But why do I tell you that? Well, because if you want to change, for example, only certain values in a copy of your array and therefore want to create a second copy of the array, you can't just write array2 equals array1. If you do that, array2 will just point to the same region of memory like array1, but it's not a second region of memory with different variables. That means if you change something in one of these arrays, the changes will apply in both of these arrays. And that's why you need to use the copy2 or the copy method. Okay, so let me show you an example how to actually copy an array. To do that, let's create another array that we call second array. And now we will write our first array name dot copy2, an opening round bracket, and then we will write second array, comma, 0, and a closing round bracket and a semicolon. The second parameter that we gave this method is basically the index that lets you start from another position on the array and only copy all those values. So in case you don't want to copy the whole array, you can put in another number, but if you want to copy the whole array, you need to put in the number 0. Okay, and now I want to mention another thing that I mentioned in an earlier video already, because I hope that this video here will wrap it up for you and now you understand what I meant by that. Because in another video, if you remember, I said a string is just an array of characters, so an array of chars. And basically, I hope now you understand why a string is just an array of chars, because that's basically how it's implemented in the backend. Welcome to the end of this video. Hit the subscribe button to stay updated. Also, if you need some high quality assets for your game or like our channel and want to support us, feel free to check out our assets at the Unity or Unreal Asset Store. You'll find the link to our store pages in the description. I hope you learned something new and see you next time.